All right, so I think these examples are labeled wrong. All right, but let's go, I'll try and fix that. Let's go through and play with these summations. Remember, converge, diverge? Fun old days. Math 151, people are into it, but you don't need to know that. We just need to be able to play with these indices. All right, so this says the summation from I equals 0 to n of r to the I is equal to this. Okay, so still induction. And I guess I would say prove by induction, but we're going to prove by induction. So start with showing it's true for 0. So if I'm going to n equals 0, so I go from 0 to 0, right? Kind of the simple stupid case on the left-hand side. So literally I plug in 0, so I get 1 on this side, right? R to the 0. And I'm going to put in n equals 0 on this side. So what do I get? I went really slow, put in 0. So I get r minus 1 over r minus 1. So the right-hand side is 1, and r to the 0, you knew it was 1. So there it is. That works. So now we're going to assume true for k. And so that means you put in n equal k. So you're adding up from 0 to k of r to the I, and then you're putting in k on the right-hand side. One place. That's it. Okay, so now we want to show true for k plus 1. So showing true for k plus 1. So I put k plus 1 in for k. I'm sorry, for n, and I put k plus 1 in for n. So I get k plus 1, so that gives me k plus 2. All right, so remember, you must use the inductive step. So that means I need to take this k up to adding all the way up to k plus 1. So you're adding 0, 1, 2, 3, here's k, and here's the k plus first term, right? Adding the k plus first term. So you're adding all these things together, right? So what that means is if I'm adding all the way up to k plus 1, that's the same thing as saying add up the first k of them and then add on the k plus first term, right? Add up all the first k terms. So this would be adding up all the first k terms, 0 all the way up to k, and then add on the k plus first term. And I need to do that because that's the only way I can separate it to be able to use my inductive step, right? Okay, so I take this, rewrite it as these two things, right? Then I retake and replace with my inductive step. So I take this out and I put this in its place, right? So this is right below. So this gets replaced with this, and then this guy carries along. So I'm going right below, right? Right below. Okay, so now what am I going to do? Well, I've got a denominator in this fraction. I don't in this fraction, so let's make common denominators. So I'm going to multiply top and bottom of this fraction here by r minus 1. So I do that, and this gives me r to the k plus 2, right? And this gives me negative r to the k plus 1. And I put it these two terms here, and it's all over this r minus 1. All right, let's see what I've got here. So here's my r to the k plus 2. Then look at what happens here. This term is positive, this term is negative, they go away. Minus 1 carries along all over r minus 1. What? Is this what I was trying to get to? It was. Ta-da. All right, so, oh goodness, these examples are all over the place. Okay, so this is for you to do. I might change the numbers on here before you see it. And then factorial. Okay, so I'll leave this for Zoom and stop the video so you can get to the next one.